Welcome back. Hopefully at this point you have completed most of the semester and you've taken most of your tests. You just have a final exam left. So we're going to go back and touch on a couple of things from before. And this would be things that might be useful for maybe the last 4 chapters of the book, but things that often I am instructed not to let the cat out of the bag on too early. Well, if you're about to take a final, it's not too early. Here is a completely worked out AC method problem. I have color-coded for your convenience. We're not really talking about the AC method. We're talking about how to use a calculator to kind of let the calculator do the dirty work. So the hardest thing about this is trying to find factors that subtract to give you a 7. In this case, a -7. What I'm going to do to kind of work my way through this is I'm going to lie to my calculator and tell it that I want a function, the graph, let's say, of what happens when you multiply my A times my C and divide it by something. Because what I'm doing is A times C, and then I'm not really worrying about signs too much right here, divided by something. And in an algebra class, I call something my X ton button. So I don't really care about the graph. I only care about the table. Now, this is from our graphing section where I get to pick my own x's. It doesn't really matter if you have it set that way or if you have it set to auto. And you let it pick x's for you because you just want it to count. This gives you the factor pairs. So 0 clearly isn't going to work. We're not counting that anyway. But 1 and 120 would be a factor pair of A times C. 2 and 60, because 20 times 60 is in fact 120. And then 3 times 40, blah, 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 blah. And then you get to 7, and 7, when you divide 120 by 7, you get a decimal answer. So we're throwing that out one. We're throwing that one out. So we're going to get rid of that one. That's not useful to me. 8 and 15. Oh, those are going to be 7 apart. That's my pair. Do you see how when I put it in here, I could just say, oh, there it is. There's my pair right here. That's where I'm getting the 8 and the 15. This is the hardest part of the AC method, in my personal opinion. This makes this faster. So what we're doing, I'm just going to review. You go to y equals, you type in A times C divided by X, and then you go to table, and you look at factor pairs until one of them will either add or subtract, depending on your problem. Add or subtract to give you what you're looking for in the middle. What's your linear coefficient? 7. The difference of 8 and 15 is in fact 7. So you know how to use that. And then it keeps on going. Here's your 15 and 8. If you want that, you see all these things that are not usable because they are decimals. Anyway, but look to the left. That's where the rest of the problem is. At this point in the semester, you should have already learned about real numbers, imaginary numbers, and complex numbers. So if I try to take the square root of -225, it'll say it's a non-real answer. And actually, it's because of a setting. So I'm going to quit. I'm going to go into mode. Right here, go over to A plus B, I hit enter. Second quit, get out of there. Let's try that again now. See how now it will answer with i's? It will also answer with complex numbers. So we have some great things we can do if that is chosen. So if I have 3, and my I key is blue right above my decimal, so 3 plus 2i, like that, times 4 minus 2i. It will give me the product. I am not saying that you should not know how to do this. I am saying that you should check your work. Just like when you multiplied regular numbers before you ever got to complex numbers, I'm saying that you should use a machine to check your work. Anyway, you have that capacity, but it is a setting. Also, sometimes it gets weird. Alpha y equals enter. If you have 2 plus 4i over 6 plus 7i, Gives you a nice pretty little fraction right there. If it doesn't give you a fraction, then you can math enter enter. But notice how it gives it to you in a plus bi form, which means that the little I is on the side over here. Looks nice and clean. You absolutely have to show your work. This will just give you a direction. And one final and very useful skill is the f of x kind of situation and what that looks like in a TI-84 calculator. So imagine you're doing those quadratics. Let's say you have a free fall problem. Something like this one. Instead of t's, I'm putting in x's. I'm not changing my variable for this. So we're dealing in feet. This might be the kind of free fall problem you might see toward the end of the semester. Now, I want to look at it. First of all, if I go to look at it, it's not going to be in the right scale. I can't see all of it. I'm going to hit zoom 0 so that I can see all of it. And then I'm going to go to window and say I don't actually need anything but quadrant 1. So I'm going to modify this so it doesn't give me other stuff. Zoom 0 asks the calculator to show you what it thinks is important. And then you can go back to your window and modify accordingly after you've seen, okay, I need to see at least this much stuff. So after I change that to just quadrant 1, now I have this. That looks much nicer. I like it. Anyway, so we look at our quadratic. We go back here. I have it saved right here in y sub 1. So f of x would work very much the same way. Here's how you find it. You go to vars, you go 1 over to y vars, hit function, and then you choose y sub 1. So instead of f of, you choose y sub 1 of. Let's say I want to find out what happens at 3 seconds. Then I use this notation just like an f of x. If I wanted to find f of 3, I would type it in just like this. Lovely. Now, another thing I could do is, if we want to find our vertex, we want to find the max height, I'm going to use my negative b over 2a situation. So I have negative b divided by 2a. That would be negative 32. I get this, and I can still say vars, y vars, enter, enter, of, and then second, and then whatever my previous answer was. Just grab that 3.75, put it right on in there. And that is your max height. Now you're going to present it on paper in a nice, pretty way. Show your professor that you know exactly what you're talking about. But here are some skills that you can use to get there in an efficient way. Also, if you have something in y sub 2, so let's say 2x minus 7, and you wanted to evaluate that, so vars, y vars, function, you just choose y sub 2 instead of 8. This is the same thing as f of 8, or maybe g of 8 because I'm using a different function. While you're learning about substitution or elimination, or right before you learn about substitution elimination, then you learn that where the two linear graphs intersect, then that is the solution to the system. So this is the picture part that goes along with substitution and elimination, and you should absolutely know how to do those things because you have to show your work. But a couple things, if you can get them into y equals mx plus b format, and I should say into function form because that's what a calculator will graph, but in this course we're going to stick with lines. The next few courses we're going to make them a little bit more spicy. But if you can get them into a function, then you can graph them and then you can see where the intersection is. But also, second trace, which is actually calc, number 5 in this menu, it wants to know where the first curve is. So first curve, second curve, and then guess because it just says I'm a machine. Maybe I'm not perfect. You hit enter a third time, and it shows you that the intersection is at 2, negative 4. Will you also have to do this by showing algebra? Absolutely. But also you know the direction that you're going with it. I like to know the direction I'm going.